Industrial engineering is a branch of engineering that focuses on making processes better. It's a lot of optimization and making those processes more efficient. So let's just go into applications and see what this even means. And let's start simple. Let's say when you wake up in the morning, your routine is you go from your room to the bathroom to shower, then back to your room to change into clothes, then downstairs to eat, then out the door to work or school or whatever. An industrial engineer would look at that process and say, what if instead you went from your room and took your clothes with you to the bathroom, showered, then changed in there instead of going back to your room, then you went downstairs to eat and leave for school or work. You just eliminated the need to go back to your room after the shower and therefore improved the process and made it more efficient. In this case, you improved time and distance you have to travel. This example is simple but clearly not a career path, so now let's see something more applicable. How can we make going through a line more efficient? At a bank, for example, everyone waits in one line normally. Then you go to whichever teller is available once you're at the front. This is nice because if one customer is taking a while, the people in line will still get to choose from the other tellers as they open, which keeps the line moving. So is this the most efficient? What if they set it up like a grocery store instead? At a grocery store, there are maybe 5 cashiers open, and people choose one line to wait in. Could you imagine something like Costco with one line that then goes to multiple cashiers at the front like a bank? Due to the amount of customers, the line would look insanely long and would probably cause a lot of people not to shop there. Therefore not efficient because it's not good for business. So grocery stores and similar places probably have the right idea. But is the bank wrong? Well, probably not. It depends on factors like the amount of customers coming in over a given time interval and the speed to which they are helped and so on. Banks often have shorter lines and less people per hour, so one line for them is probably the best way to go. All these factors are what industrial engineers need to analyze. But now let's look at something like Disney World. Places like this are huge on hiring industrial engineers. Industrial engineers analyze data about lots of aspects of the park to improve wait times for entrance, rides, food, and so on. These parks use techniques to track how long it takes someone to get through a line. Industrial engineers then take this data and figure out ways to improve how the line will move to improve people's experience. Industrial engineers will see data like the average attendance on each day of the week. If it's a low number, then maybe they can change the structure of the line. Some lines you may see weave in and out a lot if it's crowded to make it appear shorter. With new rides and attractions constantly being added, then varying attendance for different days of the week and times of the year, more data samples always being taken, industrial engineers could have very consistent work at places like Disneyland, Disney World, Six Flags, Legoland, and various other theme parks. A project you could see in class, which is also a career path, would be looking at something like Amazon. Let's say Amazon is going to build another warehouse that is going to receive, let's say, 10 million products per week that it will eventually ship out to people. So it might receive 5,000 orders of product A, 15,000 of product B, 100,000 of product C, and so on per week. The problem is, how should everything in that warehouse be designed to make the process of receiving and shipping products the most efficient? How are the trucks going to drop off the products? Should they use forklifts to take the products out of the trucks in pallets, or use more people to unload directly from the truck? What's the time it would take for each? Where should all the products in the warehouse be placed? Well, let's say if product A and product C are getting the most orders and ship out at the same time, put them closer to the door so people can load the truck quicker. Maybe put the least ordered product furthest from the door. But what if it's also the heaviest and takes the longest to move? Will that be worth it time-wise based on the orders it receives? These processes can clearly get complicated. Then a huge career path for industrial engineers would be to help improve and manage the manufacturing process of really anything. Manufacturing applies to nearly every product. Airplane parts, rocket parts, car parts, household appliances, windows, doors, game consoles, candy bars, soda and bottled water, and so on. Now, manufacturing plants are normally a lot of people, each with their own station, and often conveyor belts that move the product through the plant to the people so they can do what they need to until the product is complete. Now, you will not be one of those people with their own station as an industrial engineer. Those are the operators. You will look at the entire process as a whole, manage it, and figure out ways of how to make it better. So let's go really simple. Let's say a plant has 2 workers to manufacture paper clips, and let's say there's only 2 steps. The first worker at station A makes the straight piece of steel wire, which takes 2 minutes. Then it's handed off to the second worker at station B, who uses a machine and bends it into the paperclip shape, which takes 4 minutes. An industrial engineer comes in to review the process and sees that the second worker will have a pileup of steel wires to shape because he's finishing his process twice as slow as the first worker. So the engineer says we should add a worker to station B, so that way it takes 2 minutes to make the steel wire and 2 minutes on average to shape one. Everything flows smoothly and in the same time interval, which means faster shipments and more money. But what if we had 10 workers at station A and 20 at station B? Now we can make 10 times more paper clips to ship off, and that's even better, right? But we also have to pay 10 times more people. Is it worth it based on how much money the extra paper clips make versus the worker's salary? Are those extra paper clips even being sold that quickly, or have we exceeded the workers we need for maximum profit? What if there was like 6 stations like in the real world, and each person took a different amount of time to finish their respected job? How would we ensure minimum pileup of work or time waiting around? Are you seeing why industrial engineers are so important? Optimizing time and even profit is what industrial engineers need to do. A senior project a group of students did was to look at a manufacturing company that made buses. The company was able to make 300 buses per year, but they wanted to make 325 without adding more people or buying more machines. The industrial engineering team looked at the process, saw that the bus had to go all the way around the factory in a spiral-like square to all these different stations, like for putting on the engine, the tires, the windows, etc. Then also people at certain stations needed to communicate very often with people at another station that was far away. The industrial engineers thought of how to move the stations around so the bus had to move a much shorter distance, then also so workers that needed to communicate with each other would be closer together. This may not seem too complicated, but I had to simplify it for the sake of this video's length. But this kind of analysis could apply to any manufacturing process from paper clips to buses to fighter jets. Industrial engineers could optimize the distance nurses have to travel to deliver a blood sample to a lab in a hospital, or timing of airplane arrivals and departures at an airport so there isn't a long wait time for the plane and its passengers. Really just any process. Industrial engineering is often not high-level math, physics, chem, or anything like that. I don't want to say it never is, but it often is not. It's often looking at statistical data and coming up with solutions through testing or simulation. Industrial engineers will watch the process as it happens, maybe even take a stopwatch and time how long different processes take, collect the data, then they take that time of different processes, the cost of materials, the amount of products that need to be made on a given day, the distances that these objects travel, and come up with ways to make the process better. Note that some of these jobs are things you don't think about. Most people probably don't think Disney World lines are being continuously analyzed and optimized, or that Amazon needs to put that much thought into its warehouse layout. But these jobs do exist because all companies want to cut time and costs, and need to make sure everything gets done on time. Industrial engineers look at the efficiency of processes, but also the cost of materials, the forecasting of future materials needed, making sure everything arrives on time and in the right quantities, that all the machines are working, and so on. They improve but also manage the process. Also note, industrial engineers don't really do the design work. If you want to make lasers, design radar tracking systems, design spacecrafts that can travel faster, design military aircrafts, build synthetic body parts, and so on, industrial engineering probably is not the best for you. Industrial engineers eventually often go into manager positions where they manage people and work their way up in the company, rather than stay and continue optimizing and overseeing types of processes, but of course that is up to you. But if you like looking at the business side of things and increasing profits, optimizing the time to finish something, managing shipment orders, quantities and pricing, statistics, and working with or managing people, then industrial engineering may be good for you.